All right, here is my go at lesson 832, near the end of chapter 8. And we've had done a lot in chapter 8 that we've probably forgotten since this whole break started. And so I'm just going to start by doing a quick review, and then we'll get into the first problem. I have to do these in 15-minute intervals, and so I'll see how far I can get in this 15, and then post another one if I need to. I think I will. But this lesson, 832, is about finding the area and the circumference of circles. If you remember way back before this all happened in 831, we were doing that lesson where we were finding the area and the perimeter of all those different polygons. And we saw that as we up the number of sides to infinity, that we start getting the area and the volume of a circle. So that's kind of leads into this 832, where we are talking about the area and the circumference, just another word for perimeter, of the circle. We'll work through 8100 to 8103, but I'm going to start by just reviewing some of the stuff that we did in chapter 8 by looking at this hexagon. All right. There's a lot that we did in chapter 8. We started with doing, interior angles, exterior angles, the sum of all the interiors. We found the area of these shapes. So let's start with doing the interior angles. Remember, an interior angle is just this, if I can click on it, is just this angle. And if we want to find just that one interior angle, we have to do the number of sides, n minus 180, n minus 2 times 180 divided by n. Okay, that's how we find just one interior angle. If we wanted to find the sum, so that's one interior angle, If we wanted to find the sum of all the interior angles, we just get rid of that division of the number of sides. So if we want to find all these interior angles added together, the sum of them all, we just want to use the n minus 2 times 180, and that would give me the sum of all of them. Okay, so that's the sum of interior angles. And I am still working on my handwriting on here. Hopefully it gets better as I keep doing this lesson. All right. Other things that we did, we had that big chart that you could always go back to in your notes to find exterior angles. What I also want to talk about now is how we were finding the area of these shapes. And the area, because it was such a long process, I thought would be a good one to go over, especially as we get into this next lesson. And so if we wanted to find area, it was that step where we start at that center and we were doing like a central break. And so we'd go from the center and turn this into a triangle. All right. We would drop the apothem down, and I don't know any of the measurements, so I can't do this problem, but you would drop the apothem down, and it became the trigonometry to find what your x was. So you could find what your base was, and you could find your y, which was your height. And if you have your base and your height, you can find the area of that one triangle. And then you want to say, well, that's a six-sided shape. It's made up of 6 triangles. And so I multiply the area of that one triangle by 6, and I would have the area of my hexagon. And we've done that before, and we did that on 831 so long ago. And we won't really see that again, but just going forward, it's an important thing to remember. The last thing I want to recap quickly before we actually do get into the lesson is that idea of like a linear zoom factor and that like area zoom factor. And that was the idea that, perimeters or circumferences grow linearly, while areas have that area scale factor. And so like we say that maybe I have a square here that has a side length of 1 and another square that has a side length of 3. Well, that's a linear scale factor equaling 3, because from one side to another, side lengths are multiplied by 3. All right. Well, what we saw was linear scale factor, or the area scale factor, sorry, is just your linear scale factor squared. So your area scale factor is always your linear 1 squared, so 3 squared, which would be 9. Meaning that if the area of my shape here, let's say was 1, I don't know, let's say it's 1. That means that the area of my new shape would have to be 9, because using that area scale factor, it's got to be 9 times bigger. If you have questions on the linear scale factor, area scale factor, make sure that we try to go into the Google Meetup or Google Hangout, whatever it is, sometime next week or sometime this week, I should say, and ask those questions because we're going to use that here in today's lesson. All right, but from that, I'm going to move on. I know that was kind of quick review of what we were doing, but I'm going to move on to the first problem, which is 8-100. Okay, I'm going to read the problem, and then if you are working on it, I'd like you to pause and start working on A, B, C, and D. Now, again, if you get stuck on A, B, C, or D, continue the video and see how I do it, but I can't emphasize enough how much I want you to try to do it on your own. Okay. So 832, like I said, it's all about area and circumference of a circle. So let's start by reading it. In lesson 831, you discovered that the area of a circle with radius 1 unit is pi units squared. All right, that was like, we saw as like we had infinite amount of sides, that it got closer and closer to pi. That's because the area of a circle with radius 1 was pi units squared. We also saw that the circumference, or the perimeter, as we increased the number of sides, got closer and closer to like 6.28, which is really 2 pi units. All right, but that's in the basic case where we have radius 1. So this is going to investigate, like, what if we have radius of a circle that is 5 units or 13.6 units? Today we're going to develop a method to find the area and circumference of circles with radius not 1. You'll explore parts of a circle called sectors and arc and learn about their measurements. As we work through it, make sure you're asking yourself these questions. Is there another way to solve it? What is the relationship? What is the area? What is their circumference? Okay. The first problem here, now that you know that the area and the circumference or perimeter of a circle with radius 1, how can you find the area and circumference of a circle with any radius? Okay. So if you are looking at this problem, you might want to pause now. But in part A, it says, first examine how the circles at the right are related. All right, I'm just going to do the work below here as I extend my page. But in part A, it was something that was actually in the homework, I mean, way before all this, so you might not remember it. But the idea is that all circles are similar. All right, and so when it's saying, since circles always have the same shape, what is the relationship between any two circles? Well, they're always similar. Which means that we can use our linear scale factor and our area scale factor to help us do these problems, because we can use those scale factors when we know two shapes are similar. All right, so part A, those two circles are similar. So they are similar, and so we move on to part B, which is saying what is the ratio of their circumferences, their perimeters, and what is the ratio of their areas? Well, we know they're similar, like I just said, and so we get to use the linear scale factors. And radius is going to go up by that linear scale factor. And so when they're talking about a ratio of their circumferences, they're really talking about the linear scale factor. All right, and so the first ratio, you're talking about from radius 1 to radius 3, that has a linear scale factor of 3. Because the multiplier to take you from 1 to 3 is 3. All right. Well, once we know the linear scale factor, we know that the area scale factor is just the linear one squared. And so our area scale factor, or our ratio of our areas, is going to be the linear scale factor squared. So my area scale factor is 3 squared. And that's going to be 9. All right, and those, I know they use our fancy words, ratio, the ratios and of perimeters and the ratios of areas, but it's really just talking about these linear scale factors and area scale factors. Again, being able to use that because we have similar shapes here, similar circles. Now we'll move on to part C. Part C is saying we're going to actually use these linear scale factors and area scale factors. If the area of a circle with radius 1 is pi, then what is the area of a circle with radius 3? With radius 10 or with radius r units? Okay, and so we have that radius was 1 and it was pi. So we'll start with what is the area of a circle with radius 3? Well, if the small shape, the small circle, has a area that is just pi, then the larger circle with radius 3 has to have an area that's 9 times bigger. And so the large circle has an area that is 9 pi. And I should say the large circle, I should really be more clear and say large is actually this one with the radius 3. All right, 9 times bigger. It's got that area scale factor of 9. Okay, now what about if it was, instead of radius 3, it was radius of, what did they say, 10? Well, that means our radius has a linear scale factor. Our linear scale factor went from 1 to 10, so our linear scale factor is 10. That means our area is 100 times bigger, or 10 squared bigger, which means that our large shape, if it was radius 10, would have an area that is 100 pi. It's your small one times your area scale factor gives you that 100 pi. If it was R units, it's the same kind of idea. You're going from radius 1, to a radius that's R. And so from 1 to R is a linear scale factor of R. If your linear scale factor is R, then your area scale factor is equal to R squared. And so your area, if you have a radius 1, your area was pi, and that was the small circle. And then if you have radius R, your new area would be pi times R squared, which is actually how they come up with the equation, or the formula for the area of a circle. All right, and that one we'll be using quite a bit. So this equation here, even though it's written really poorly, that equation will always come back around. Pi times R squared is how we can find the area of any circle. All right, so we'll move into part D. And that big idea in C is to just realize that we can still use the idea of area scale factor to grow our circles. In part D, it's saying if the circumference, the perimeter of circle, if the circumference of a circle is 2 pi, and that's with radius 1, then what is the circumference of a circle with radius 3? Well, in part C, we were growing our circles using area scale factor, because we started with that area being pi, and we wanted to say, well, what was the area of the larger one? Well, we used the area scale factor to say, it was 9 times bigger, or 100 times bigger, or R squared times bigger. In part D, we saw too on 831 that perimeter or circumference grows with the linear scale factor. So instead of using area scale factor like we did in part C, in part D we're just going to use the linear scale factor. All right, so in part D, if the small circle has a circumference that is 2 pi, and you have a circle, so the small one has, I should really write radius 1, but then you go to a bigger circle that has radius 3, well, we're going to actually use linear scale factor, and from, radius 1 to radius 3, that's 3 times bigger, and so our circumference is going to be 3 times bigger. So our radius of our circumference of our circle that's radius 3 is 6 pi. It's 3 times bigger. If we go up and it says, well, what about with a radius 7? Well, the small one again was 2 pi. So if we have radius 7, that radius is 7 times bigger, linear scale factor is 7, and so then our circumference of our bigger one, our radius 7 one, would be 14 pi. And lastly, if it was radius R, I think I'm going to run out of time, so I'll continue it in the next video, and we'll move on to problem 8101.